Perfect numbers. These are those numbers whose divisors when added gives twice the number itself. Interestingly, these numbers are not easily found. So, is there any way to find these numbers? The answer is yes. Euclid had derived an amazing way to do that. Let's define a function sigma, which takes in a number and gives the sum of its divisors as output. Now let's play around with this number. What if we take a prime number as input? They have only two divisors, so the result is obviously the number plus 1. We can clearly understand that if the output is twice the input, then we have a perfect number. So clearly primes can never be perfect. Now what if we take powers of primes as input? Quite natural, the smaller powers are the only divisors. But wait, the output is a geometric progression, so the sum of the terms will obviously be this. Now let's take an example, say 28. What if we take 7 common from the last 3 terms? A bit of factorization. Wow, that's interesting. The first bracket is basically sigma of 4 and the latter one is sigma of 7. And interestingly, 28 is 4 times 7. So from here we can have an idea that sigma function is multiplicative in nature. Now what if we plug in 2 to the power m? Pretty obvious, 2 to the power of m plus 1 minus 1. So we have this. Now let's assume that this term is a prime number. Plugging in this term gives us 2 to the power of m plus 1, which is 2 times 2 to the power m. Probably we can do something with this. Assuming 2 to the power m times 2 to the power m plus 1 minus 1 as input, we get the following expression as output considering the multiplicative property of sigma, and 2 to the power of m plus 1 minus 1 is a prime number. We can freely apply this multiplicative rule as 2 to the power m and 2 to the power of m plus 1 minus 1 have no common factors. Simplifying, we get a bit of rearrangement, and yes, we are done. Output is 2 times the input. So yeah, we can predict perfect numbers if we have an idea regarding when this number is a prime, and it has a special name. They are called the Mersenne primes.